I'm going to talk about what is a black hole and I will show what will happen to Earth if it's closer to the black hole. So let's open a new simulation and put the black holes. So pause the video. It's gonna be 3 times I did it. So otherwise it goes too fast. Most of the time it's going too many times. So it's going to go realistic, close to realistic times. So it's too fast. So let's open a new simulation and then we do Mars in future videos for now. So let's choose a random black hole. Slower than time in milliseconds, so it might be too slow, too fast. So auto orbit this. It won't auto open until gravity attacks comes. It's going to be, or the temperature changes so fast. That's the limit it could go. Sound of there's a limit. So the temperature goes up because the gravity is splitting the Earth into pieces. Then it goes inside a black hole. So the temperature rises around like 4,500 degrees Celsius. This is on Celsius, so good changes to Kelvin Fahrenheit. So and there's some dust coming out, and this is just a simulation. It could be close to realistic levels. So let's go time slowly faster up to don't know. So if it's glitching, that's lagging, that's normal. So you can see like there's some dust like going around the black hole. That's what happens in space when like in real life. So I already discovered by like using like past like black holes, what does black hole do that did in the past. So all the parts of it is gonna like shoot out from the black hole's orbits. So that's an example of a black hole. So let's do. So where is Earth located? Could be wrong places. So Sandbox just do the wrong places. So might be. It's gonna look like this. Like this is the current the location of Earth in real life, but it's gonna be somewhere north. The simulation shows like this, but it's gonna be showing a little bit different. So it's gonna be, let's look at the actual. So Earth's orbit during December. So this then instead of Earth being here, like Earth being, you can't say it because there's no name star on it. So this is gonna be flipped around. The Earth is actually the flipped directions, so of the opposite place of right now in Sandbox. So this is the Earth is actually right here, so it's in December time frame. So close to no December, but it's normal for now. It's gonna be opposite of this place, so it's closer to Venus than the actual place right now. Like, but Venus, the rest of Atlantis is opposite direction. So of this, so let's see what happens when a dinosaur asteroid hits the Earth. So it's gonna take a while because they do search how fast the asteroid is. So, like the dinosaurs, we are the boss the simulations. So the dinosaur are destroyed by some realistic lighting show later. So the shoes are random. Thunder doesn't show up minor object. So random asteroids. So not gonna hit Mexico, but so let's do 65 kilometers per second, kilometers per hour. So it's gonna change to kilometers per hour. So 65. So dinosaur asteroid actually. So it's gonna be 20 kilometers per second, not 65. Could be 25, but it's gonna be actually 21 is closest, but it's only 20 kilometers per hour, so per second. So that's on boss time, but it's gonna go 2 minutes at a time. It's the most accurate in the simulation. So it's too fast. So, so when it hits the earth, the tsunamis, earthquakes, and natural disaster is gonna go. When the asteroid hits Earth, it releases energy that causes earthquakes, tsunamis, hurricanes, blizzards. And that time, maybe smog blocking sunlight, it causes temperature to drop in some places and in this place. So this is the, so if we turn on ballistic view, turn off space goggles. The sun is gonna be this bright, but it's not the actual one. It's not the actual impact brightness of the asteroid impacts. So let's look at the actual brightness of that asteroid hitting Earth. So let's turn off space goggles, which is why it be low visualization. So turn it off. So it's gonna hit the random place instead of Mexico. But if its sun gets too bright, so let's choose a random launch it to hit Mexico if possible. So I'm gonna call it Chicxulub. So it's gonna take a while to set up everything to dinosaur asteroids. So 20 kilometers per second. That's why it stays quiet for a while. So let's unpause the video as possible. Video. So simulations. So there's another way. So let's set up everything. So it's already told before them. So they need to tell. This is the actual brightness of the asteroid impact. So let's double check if it's actually on. So it's gonna hit Mexico. So Mexico is gonna live it off. So it's gonna see like brightness like this, but it's way more brighter than it, realistic than, but it's way less realistic. So the simulation, Sandbox. So let's see what happens if it cools down. You can see there's some land and water changes and climate changes. So this is so I don't know. You might see this right here on the right side of the screen. So let's see Mexico. Nothing has changed. The climate doesn't change unless I hit with Mars size objects. So let's see if Mars size object hits the Earth. It's going to be part of Earth's history, not the whole thing. So slow down time for until 2 minutes per second. And let's pause the time. Mars sized object hits the Earth. So this is what happened like 4.5 billion years ago. So let's unpause time. So when it hits the Earth, no, it's too fast, too slow or fast. So let's. So how fast? But it's not full Earth history yet. So there's some apocalypse like dinosaur, like not dinosaur, like apocalypse hitting the Earth like April 13, 2029, but it has a lower chance, like below 10%. But so this is one. So let's slow down time to 2 minutes per second. That's the most accurate. So and turn off space goggles. So and put in moon. We could do moon size, but put in this D out something. So launch pause time. So it's gonna hit North America. So let's change it to 9.3 kilometers per hour per second actually. So unpause time or need to was off. So let's take view. So it's gonna be night and white and one side in daytime is better. So but it has no atmosphere in 4.5 billion years ago, so atmosphere is still growing that time. So where this is going to see some effects before it hits Earth, like volcanoes, earthquakes, not tsunamis because water doesn't exist. It could be this bright, like 4.5 billion years ago. In this simulation, it shows less bright. Simulation shows this bright, but it's not true. But the real life is different. So it's happened 4.5 billion years ago. This. How do you know this? Earth is 4.5 billion years ago. The moon formed because of fossil evidence, not ice cores, like there's no fossil, but it's like radiometric dating, so not fossil, but so it's gonna be super too bright to see. So and it's the speed of time. So the particle will shoot out. Some of the particles, and then some of them will collide with each other and form the moon. So and let's look at the sun in 4.1b. It will go super. It will turn instantly into the red, smaller when I do this. So let's see what happens when the sun turns into red giant. So this is not a true version of like turning into red giants. So but it's gonna go same size and then get bigger, and then go shrink. This is not true. This shows up the simulation. When the sun gets too big, it turns to black hole. But actually, it's gonna happen like it turns into red giant when the sun is burning hydrogen. So this is the end of the video. I already showed everything. So